Okay, so you know how regular expressions work, and you have seen how they were applied, starting from the very first chatbot, Eliza. What then happened later on in AI is the development of a standardized language for writing these patterns, the artificial intelligent markup language, AIML. Until then, in the beginning, basically every chatbot had its own implementation, its own pattern matching. And obviously, when you have a framework where you can just develop your patterns and load it into an existing system, it makes testing, development, and sharing a lot easier. So in the 1990s, there was the first development towards an open standard for chatbots, this AIML markup language. It was used in the well-known chatbot Alice, but also many other chatbots. You'll see the regular expressions, the rules are written using XML, and then there is a kernel that loads these patterns and does all the matching, response generation, and so on. So here's an example how this can look like. We have a number of categories with a pattern and a template for the answer. So here, when we have a pattern like hello, followed by anything, and note that it's case insensitive, so it doesn't matter if it's lowercase, uppercase, or mixed. Then if this pattern is found and matched, this is the response that will be generated. If you ask, for example, what is your name? And again, it doesn't matter what the capitalization is, and any kind of punctuation marks are also ignored, then it will generate the answer. Like here, I am Concordia University bot, your helpful assistant. There are a few more examples here. In this case, you can see that you can have multiple groups of patterns. For example, anything that falls into the one of the input categories here, followed by one integer in the categories here, would generate the template response here. So how do you work with this in Python? There is kind of a good news, bad news situation. There is support for AIML in Python, quite a few different libraries, but the sad news is that they only support version 1.0 of AIML and not the more powerful version 2.0, which I'll talk about in a minute. So again, the way it works is you'll need to have an AIML file in XML with your patterns. So here we have a reaction to two possible greetings, a normal greeting and a kind of insulting greeting, and a different response to each. Then you just import the AIML bot library. You generate a new bot using the AIML file with the XML description. And then once you have the bot, you can ask it to respond to various inputs. So if you say something like hello, whatever, it will match this pattern here and generate the answer there. So this is something we'll also try out in the lab. You're not limited to fixed question responses, just like I've shown you with Eliza earlier. You can have, for one input pattern, multiple random answers. So even if the same input pattern is found, it will pick randomly one of these, in this case, 3 answers here. Likewise, for the second possible greeting, there are 2 random responses here. There is a way to store a state during a conversation. So you can have, you can establish a session with a user. So for example, the user logs in, you know the name, the email address, the username, or you have some other idea about the state. For example, a session variable. And then you can store information in a key value store. So for example, you can have a pattern like here, where somebody talks about the dog. And then you can store the name, you can store the information that was matched here in using the key dog, and then later retrieve it for a possible answer. So if a conversation goes like this, my dog's name is Max, then you generate the answer. That is interesting that you have a dog named whatever was here, Max. And then if the user asks again, possibly in a later session, what is my dog's name? It will answer, your dog's name is Max. So this bot will remember things for you. So this is AIML1. In AIML2, it was extended to make more modern bots possible. So things like hyperlinks, rich media, images, and so on that are not possible in 1.0 are possible in 2.0. So you can generate, for example, cards that look like you find them in modern assistants on a mobile phone and also on the web. So, but again, I mentioned that the standard 2.0 is not available in Python and in general has limited availability and libraries. So the people behind AIML that also developed AIML 2.0 created an online startup, the Pandora bots, which is another well-known framework for developing bots. And here you can see the trend, what happened over the last 5 years, which is moving to a cloud-based development for bots. So a lot, not all, but a lot of the bot development nowadays happens in these cloud-based environments. I showed you the one from Microsoft. I'll show you later the ones from Google, from Amazon, and so on. So essentially what you do is you develop your bot, you write your rules, and it has features for integrating with other platforms. So you don't really have to worry about integrating with Skype, Line, Slack, Telegram, and so on. It will take care of this for you. And you can deploy it onto the cloud. It has online tracking, analytics. You can see how much it interacted, how many answers it generated, and so on. So this is, of course, nice on the one hand, because you get a lot of functionality using these cloud-based environments. The downside, obviously, is that they are all completely incompatible. If you invested a lot of time in making a bot on the Microsoft platform, you cannot export it and then import it to another cloud-based provider. So you basically have a vendor login. Once you went with one of them, it's not possible to take your bot and go somewhere else. And this is yet another reason why you have this huge amount of different startups and established players. So all the big companies have their bot framework, Amazon, Google, Microsoft, IBM, and so on. And then there are lots of startups as well. Possibly, most likely, like it happened in other areas, there will be some kind of consolidation, perhaps move again to a new standard that makes interoperability a bit easier. But for now, we are in the state where you basically have to choose doing it yourself with one of the available libraries or moving to a cloud-based platform, and then being aware that it will be a major cost if you want to switch the cloud-based provider. Let's talk about a few more of those. Another one that was very well known is API.ai. So you've seen that AIML being born in the 90s had this somewhat clunky XML-based representation. So people, of course, looked into making something that's more user-friendly, developer-friendly in the early 2000s. And one of those was API.ai. So they developed, again, their own proprietary language for dialog specification, but it was very intuitive and a lot of people picked up on it. And it had features for storing history, user preferences, location, and so on that made it very useful for modern bots developed for websites and mobile applications. So this was, again, done by a startup, SpeakDroid, developed in 2014. And some of you might remember what happened to it. It was bought by Google in 2016, and Google renamed it in 2017 to Dialogflow. And this is the system that now powers Google Assistant, a lot of the other services by Google, and that you can also use again on a cloud-based platform to develop your own chatbots. So if you go to Dialogflow, you can watch a quick introductory video on how this works, and you get an impression how the development interface looks like and how much you have to pay for it if you want to use a bot this way. And again, this is the same approach that other companies are going for. So Amazon has Lex. So again, the technology that's also used in Alexa, you can use for developing your own chatbot. And yeah, again, have a look at the website. There's also a quick introductory video where you can see how the bot works and how you can develop and deploy a bot using Amazon. So one of the new features that most of these frameworks have is that they remember a state in the current conversation. Remember, many of these bots are task-oriented, so they have to be able to do a certain task for you. For example, in an Internet of Things environment, controlling some devices in a smart home, turning light on or off, or changing the temperature, or on a mobile device, setting an alarm, creating a message. So to make these conversations more focused and also make it safer, making sure that you don't misunderstand what's going on, you can introduce various tasks. And once you recognize that the user wants to do a certain task, you can interpret the communication within that task. So once, for example, they know you want to book a ride, then all the other requests will be focused on the context of finding a ride, booking it, paying for it, and so on. If another task is controlling temperature or light in the house, then you know that all the next upcoming conversations are about home control and not about the ride booking. So this helps a lot in, for example, reducing ambiguities and misunderstanding in the context. All right, so much for pattern matching bots. And in the next part, we'll talk about rounding-based bots. See you then.